This is being recorded live, period 7-8. If you've got a question, you don't want to be on this, please make sure to just save them until the end. Otherwise, if you want to, you're more than welcome to. Today we're talking about properties of logarithmic functions. One of the nice things about these is that if you go on to the next class, you definitely learn them. You might learn them a little bit later in the year. So we teach them in Algebra 2 to kind of get you prepared for any chance that you'd see them on the SAT or ACT if you're going to end up taking any of those tests. The big concept that you need to understand is that you can either expand logarithmics or you can contract them into one condensed form. Multiplication means addition. Division means subtraction. And anytime that you have an exponent, you can pull it out front. Those are what those three properties are really looking at whenever it comes to those product, quotient, and power. So I'm going to take you through a couple different compressions where you have multiple things that have a log base and they all have the same log base. And we're just putting them in so by the end we only have one log base for our answer. So very similar to PEMDAS, we do move left to right. So we've got log y2a minus log yb. We want to condense those. And as I said at the very beginning, okay, division and subtraction kind of go hand in hand. So I'm going to rewrite these as one log, which is 2a divided by b. From here, addition and multiplication also go hand in hand. So these two, okay, I'm going to create a multiplication where I have log base y to 2a over b times bc. Which really, if this is over 1, I've got a b in my denominator, a b in my numerator, which gives me my answer of log base y to the 2ac. Okay, so I call it contracting because what we've done is we've taken three different bases, we've put them all together into one and simplified pretty nice. Questions, or does anyone need more time at all? I put the BC over 1 just to show you that it's in the numerator. You don't have to put it over 1. I've had a lot of students that have been confused with, the denominator, numerator, like which is where, so kind of helps. Yep. Why is it log? Say that again, sorry. So whenever it's addition, you cram them all together as multiplication. Is all. So like I did the division, the subtraction becomes the division, and then from there we want to do the addition. And we just want to move left to right unless we have some type of parentheses. Like you see in example number 2. Okay. Now number 2 also has a number out front. Anytime you have a number out front, that can actually be your exponent. That's that power property. So I'm going to simplify that first. Log base b is the x cubed. And then minus, this can all be multiplication. So I'm going to put this all as log base 4x. And then from here, we have our division. So this will be 1 log base x cubed over 4x. I have 3 x's on top and 1 on bottom. So I can simplify this to become log base x squared over 4. Yeah. Why don't we do the square root of that so that then if there was an equal sign, we would totally simplify it more. But because there's no equal sign, we're just trying to simplify it into 1. We don't have to worry about that step. Yeah, good question. All right, example numbers 3 and 4. Now we're going to talk about expanding the logarithms. I feel like this is the part where it gets a little bit easier whenever it comes to doing these. So notice here that 7 and b are multiplied. This is multiplication. So I'm actually going to split this up into two different logarithms with the same base. Log of 2 is 7 plus log of 2 to the b, and use addition property. This right here is my final answer. I don't have to do anything more because I don't have an equal sign. I've simplified it and expanded it into the biggest part that I possibly could, and that's it. Now, just like multiplication and addition go hand in hand, with example number 4, division and subtraction do as well. Notice, though, that there's this 2 on the outside first. I'm going to move that to the very front using that power property. So 2 log y over 3. And when I'm doing my subtraction, so I'm going to rewrite this 2 parenthesis log of y minus log of 3. I'm keeping that parenthesis around it because of the fact that it goes to both the y and the 3, that exponent of 2 that we pulled out front. If it was something a little different, maybe it looked something like this, log of y over 3, and maybe this was y squared 3, then it would be a little bit different here. We would be able to do log y squared first minus log 3, and then pull that 2 out at the very end. Okay, so depending on whether you have that parenthesis there or not determines whether you have a parenthesis in your answer or not. Okay, different example there. So there are 3 other properties that I want to share with you. I think they're going to make your life a little bit easier, especially when you're solving for calculator type material. The previous lesson, we had talked about how when you plug something into a calculator, it has to be a log base 10. With the change of base formula, that is not the case. Let me show you the example that I have for you. I'm just going to throw out here, I'm just going to say I've got log base 10 of 5. So pulling up my calculator. Yesterday I said log the 10 is already there. The base of 10 is already there in your calculator. So from here I could just hit enter and I get my answer 0.6989. If I use the change of base form, I would type in the log of 5, parenthesis, divided by the log of 10, parenthesis, and then hit enter, and it would give me the same exact answer. Do you have to do that for a log base 10? Absolutely not. But something that's a little different, say for instance you had like log base 3 of 7 and you wanted to know what it was. You could easily just do log of 7 divided by the log of 3 in your calculator and then get your result. So it makes it a little bit easier for you to do. Also, the other 2 properties that we have here is if you have a log base to the same number, which has an exponent, then your exponent is your answer. And then if you have an exponent, or if you have a base with an exponent of a log base, and those 2 things are the same, those 2 bases are the same, then your answer is whatever that value is out front. Another good example that I like to give everyone, just with numbers, is if I had log base 3 of 3 to the 4th power, my answer would be 4. Or if I had 3 to log base 3 to the 4, my answer would be 4, just based on the fact that those bases are the same. All right, take a look at example number 5. Use change of base formula to find the value of each of the following. The first thing that I think I'm going to do here is I'm going to move the 8 out front using that power property. And then in my calculator, I can type this all in as 8 log 27 divided by the log of 3. Just go ahead, type that into your calculator, and you'll get your answer. It would just be, yeah. So your answer here would really be 8 times 3, which is 24. Once you plug it into your calculator, the log base disappears. It just becomes whatever that number is. If you plugged it into your calculator completely, you automatically would have got 24. If you didn't and you just plugged in the 27, log 27 or log 3, you just would have gotten 3 to multiply by the 8. Any questions at all so far? All right. Take a look at example 6. We've got the log base 8 of 8 all to the 5th power. Okay, those bases and number are the same. So right here, this is just a 5. And then I've got a base of 3 with a log base of 3. Those will also cancel. And I'll be left with that number of 8. So 5 plus 8 will give me 13. And that will be my answer. All right, example number 7. I want to try and condense these into one. So what I'm going to end up doing is I'm going to pull this back to make it an exponent. It's log base 12 of 6 squared plus the log base 12 of 4. Now the log base 12, 6 squared, that's really 36. And because this is addition, I'm multiplying. So it's 36 times 4, which gives me log base 12 of 144. I can then plug that into my calculator as log of 144 over the log of 12 to get my answer. Anyone try it and get an answer that they're willing to share? 2. Thank you. And there you go. All right. I'm going to save these for another video. If you're watching, I'm going to save these for a different day, for a different video, something for us tomorrow. But that should be all.